Welcome. In the first part of Chapter 13, we discussed the layers of the atmosphere and the chemicals that made up the majority of the atmosphere. In Part 2 of Chapter 13, we will continue to talk about pollution and some of the technologies that have been developed to combat it. Pollution itself is a naturally occurring phenomena, and it's described as any chemical or pollutant existing in an area where it shouldn't. Wildfires, dust storms, and volcanic action are all natural forms of air pollution that have occurred over thousands and thousands of years. A pollutant is any substance that is in the wrong place at the wrong time. Historically, humans have always released some level of pollutants to the atmosphere and have impacted the environment through clearing forests and use of fire. With increased urbanization and globalization, the amount of air pollution that's produced has exponentially grown over the last 200 years. In some places, air pollution is far worse than others. For example, cities generally have a higher amount of air pollution than non-cities. And even in some places like China, there's tremendous levels of air pollution as the economies are industrialized.
In many developed areas, smog is a huge concern. Smog is a contraction between smoke and fog. It's going to contain a lot of the air pollution that's released from smokestacks. When air is polluted by industrial activity, this is termed industrial smog. Let's take a look at some of the chemicals that are present in smog. The first set of chemicals that we have to look at are the oxides of carbon. When coal is burned, several chemicals are released. Coal contains mostly carbon, but it also contains sulfur. When coal is burned, the carbon is oxidized into carbon dioxide and carbon monoxide. Soot is also produced in this process. You can see here the chemical reaction for the oxidation of carbon into carbon dioxide. Solid carbon reacts with oxygen gas to form carbon dioxide gas. In some cases, when there's not enough oxygen to fully oxidize the carbon dioxide, carbon monoxide is formed, or CO. These are both gases that enter the atmosphere. Any of the carbon that's unburned remains as soot, which is like a black ash. Coal also contains sulfur. When the sulfur is combusted, it produces sulfur dioxide in a similar oxidation reaction. The sulfur combines with oxygen gas to form sulfur dioxide gas. Sulfur dioxide can be further oxidized with another molecule of oxygen to form sulfur trioxide. If you recall, sulfur trioxide is one of the acid anhydrides that we discussed last chapter. That means sulfur trioxide can react with water, forming sulfuric acid, which can lead to acid rain. Not all of the products of smokestacks are gases. Some of them are solids. These are called particulate matter. Any solid or liquid that is larger than an individual molecule and does not combust. Some of the particulate matter will remain in the combustion chamber, but many of it will fly out of the smokestack and mix the fly ash with the smog that's released. There are several negative effects that can occur to human health based on the industrial smog, especially depending on how dense smogs are in particular areas like major cities. The particulate matter and sulfuric acid can harm the health of the lungs. This synergistic harm to the health of the lungs causes the alveoli to lose resilience over time, and lung damage to occur, resulting in shortness of breath and pulmonary emphysema. There's also environmental damage that occurs due to the acid rain and then the particulates damaging crops or other plants. The acid rain can also decay some of the infrastructure of buildings. Several technologies have been developed in order to minimize the amount of pollution that's being released from smokestacks. The first one of these technologies that we will discuss are electrostatic precipitators. These use an electrical charge to attract some of the pollutants onto an electrode. The plate that attracts these pollutants will maintain a positive charge and attract the negatively charged pollutants or fly ash. The next technology that's utilized is bag filtration. This works like a giant vacuum cleaner and allows the particulates to be filtered through a series of bag houses. A cyclone separator can also be used to reduce the pollutants from a smokestack by spiraling the gases in a circular motion. This cyclone separator will pull the heaviest particulates to the outer walls of the separator and remove them from the gas stream as it leaves the smokestack.